We are going to look at how to draw the Lewis structures for a couple of ions. The first one we have here is the nitrate ion, NO3 minus. The first thing we should do is to start with counting the total number of valence electrons present in each of the atoms. Okay, so we have 1 times nitrogen, so 5 valence electrons, because nitrogen has 5 valence electrons, and we have 3 times oxygen. Okay, each oxygen has 6, so 3 times 6 is 18 electrons. And because the nitrate is an anion, the negative charge should be countered. So for that, 1 time a negative charge, 1 electron should be added to this. So totally we have 19, 24 electrons. Okay. Now, the way we draw this is, in this species, nitrogen is a central atom. Nitrogen is a central atom. We draw nitrogen, and then around this we draw the 3 oxygen atoms. Okay. Now, what we have to do is to connect these atoms together. Okay, all the 3 atoms to the central nitrogen atom through 2 electrons, because 1 bond requires 2 electrons. Same way, another pair connecting these 2, and a third pair connecting the oxygen and the nitrogen. Now, 6 electrons are gone. Okay, we still have 18 electrons. We have to distribute the remaining 18 electrons among all the 3 oxygen atoms. Okay, let's do that. 2, 4, 6, 8, 10, 12, 14, 16, and 18. And the molecule as a whole has a negative charge. Okay, so nitrate ion. Now, we have to convert this structure in a way we can simplify it. So I'm going to draw the nitrogen in the middle as such, and then I'm going to convert the bonding pairs into a single bond. Okay, these and these 3 pairs of electrons are called bonding pairs, bonding electrons. And these other pairs around the oxygen atom, these are all non-bonding electrons. Okay, these. Okay. So with the bonding electrons between the atoms, we can change that into a single bond. Okay, oxygen, 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 and then fill up the remaining electrons like this. We have a complete octet for all the 3 oxygen atoms, with, of course, the negative charge on top. However, this nitrogen central atom doesn't have an octet, so 2, 4, 6, only 6 electrons. So what we have to do is move one of the pairs of electrons into this system, NO system, meaning 1 electron stays here, the other electron goes over to this side to make a double bond. So the same thing can be drawn as, I'm going to use the same color. Okay. And this can be drawn in a different resonance structure, okay, using the double-headed arrow. Okay, I can move the bond into that. Okay, so keeping these intact, I'm going to convert this double bond into a single bond, and you have extra pair of electrons there. This single bond has now become a double bond because of the lone pair here. So that pair is gone into the bond. So we only have 2 pairs. You can draw it like that. Okay. So again, still the negative charge on it. So this is how we can draw the Lewis structure for nitrate ion. Let's take a look at one other example where we look at the sulfate ion. Okay, SO4 2 minus. This is sulfate. Okay, sulfur has 6 electrons, and oxygen, okay, 1 time S. Okay, oxygen 4 times oxygen. We have each oxygen has 6 electrons in the valence shell, so 24 electrons. Okay, and there are 2 minus charges. Okay, 2 negative charges, so 2 times negative. That should add up 2 more electrons to this. 2 electrons. So 24 plus 6, 30, 32. 32 electrons total. The way we draw the Lewis structure for this is slightly more complicated because the sulfur is going to accommodate more valence than 2. So it's going to have a structure like this. As a skeleton we can draw, because like we did earlier, each bond means there are 2 electrons in this. So 1, 2, 3, 4 bonds, 8 electrons are gone. Okay, if 8 electrons are gone, so we still have 24 electrons remaining. We need to distribute the 24 electrons among all the 4 oxygen atoms. So starting here, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Complete. Okay, 24 electrons used up. So everything is used up, and the molecule as a whole, okay, has 2 negative charges. And something like we did here in the case of nitrate ion, we can draw Lewis structures using resonance, because the central atom already has an octet. However, these can be pushed into the system. Okay, so that we have a structure as shown here: the double bond, single bond oxygen, double bond oxygen, 2 pairs, and O2 minus. Just like in the case of a nitrate ion, the 2 negative charges are delocalized, or the excess electrons are delocalized throughout the skeleton. So you cannot say which oxygen carries the negative charge. It's pretty much uniformly distributed throughout the molecular skeleton. So this is how we can draw the Lewis structure for sulfate. Keep in mind, the sulfur is an exception for the octet rule, which means you can have more than 8 electrons surrounding the sulfur. Okay,